I just shared my screen, so you should be able to see. Now say yes in the chat if you can see the screen. Say no if you can't. All right, yes, very good. Okay,
Yes.
let's begin. Today will be the 5th lesson of factoring and polynomials. Mostly we're focusing on quadratic equations now. I think after this class, we might have a little one about graphing quadratic equations, but that's not too important right now. Okay, so for today we'll do some review problems, just the homework problems. We'll review the quadratic formula, and I'll introduce completing the square as third big method to solve quadratic equations. And then I'm gonna do some practice problems, and also I'm gonna prove the quadratic formula with completing the square, and that's why we need to learn it. It's very effective sometimes. Okay, so let's start with some homework problems. All right, and you could have done these either way. So I'm gonna just show it either way. So everybody just put your answers in the chat. Okay, so I'll give you a few moments to put your answers in the chat, and then I'll go over the answers. Okay. All right, so let's look at the answers. So I think people said -2 and 7. So let's look at that. So there are two ways you could solve this that we've learned thus far. So you could either use factoring or the quadratic formula. For this specific case, I'd actually recommend factoring instead of the formula because it's very easy to factor. You can easily see that it's going to be x minus, or not x, m minus 7 and m plus 2, right, is equal to 0. Therefore, you get m minus 7, or m plus 2 is equal to 0. And then you get m is equal to 7 or -2. So it's very fast, right? But we learned about the quadratic formula last class, so let's use that as well. So m will be equal to, so the quadratic formula is -b plus minus square root of b squared minus 4ac all over 2a. So let's look at this. First, it's sometimes helpful to list the a, b, and c numbers. So a is 1, b is -5, and c is -14. Don't forget the negatives. All right, so it's going to be 5 plus minus 25 plus 4 times 14, which I think it's going to be 56, right? So 56 here, okay? And that's just going to be 81, square root of 81, so we can solve that later. And then it's all over 2, right? So that's going to be 5 plus minus 9 over 2, basically equal to -4 over 2, which is -2, or 14 over 2, which is equal to 7. And we've got our answer, okay? So both ways are pretty effective, but I definitely recommend factoring if you can. All right, so let's try this next problem. Remember that you need to make it equal to 0, okay? So you gotta whenever it's not equal to 0, you gotta move the terms to the other side to make it equal to 0. All right, so I'll give you a few moments to do this one, and then you can put your answers in the chat as well. All right. So let's look at this next one. Okay. So for this one, you need to move the negative n squared to the other side. So it's going to be um 9n squared plus 4n minus 16 we've gotten so far, right? So then let's list our a, b, and c terms. 9, 4, and negative 16. So then using the quadratic formula, this is going to be negative 4 plus minus 16 plus 4 times 16 times 9. So this is going to be quite a big number. So let me use my calculator for a second. So let's see here. 9 times 16 times 4 plus 16. Okay, so it's just this over 16. Okay, so this is quite an ugly number. So it's going to be negative 4 plus minus the square root of 592. So let's see if we can simplify this a little bit. So divided by 4 is divided by 4. Okay, so it's 16 times 37. So therefore, this is going to be equal to negative 4 plus minus 4 times square root of 37 over 16. It's negative 4 plus, well, not negative 4 anymore. It's going to be negative 1 plus minus square root of 37 over 4. Okay, so it's really ugly, but that's what you get when you use the quadratic formula. You couldn't have solved it with factoring, I don't think. And if you used another method, you would have gotten the same.
Wait,
uh,
how
you
is
got
how did a equal 9? It didn't equal 8.
you move this to the other side.
Oh, yeah. Oh, yeah. Okay.
All right, so let's move
How
on
do
to the
you
next
get
one.
16 on the bottom?
It's just 2 times 8, 2 times a.
But didn't we change it to
Oh wait,
9?
sorry. Right, you're right. Okay, let's change this. Good catch. Who was that? Thank you for reminding me. All right, so if we do this, then simplify is different. Thank you so much. Okay, so small computational error. Let's go back here. It's going to be negative 2 plus minus 2 square root of 37 over 9. There we go. All right. Now that we're done with that, we can, no more problems, right? So whoever was that, thank you for catching my mistake. Let's move on. All right. Let's see our answers. We have 9/4 and -4. All right. 2 people got the same answer, so I think should be correct. Let's test this, okay? So remember, move x to the other side. We want to set it to 0, right? So let's see if we can factor this. We have 4 and we have 9. We can actually factor this. All right, so we can factor this. So it's going to be x minus 4 times 2x minus 9. So we factored it, right? Well, plus 4. Okay. So, and that's going to be equal to 0. So then you get x is equal to -4 and x is equal to 9/2, right? Is that correct? All right, so 9/4 is incorrect. All right. So, anyways, that is our factoring method. Okay, so let's do our method with the quadratic formula. So a is 2, b is -30, well, -1. Because we moved x to the other side, so it's going to be -1, and then it's going to be -36. Okay, so then if you plug it into the quadratic formula, it's going to be equal to 1 plus minus the square root of 1 plus 72 times 4. 72 times 4 plus 1 is going to be 289, which is pretty sure it's the square root of something. And that's going to be over 4. Okay, so let's look at this. So the square root of 289 is going to be 17, right? So that's 1 plus minus is 17/4. It's either 18/4, it's -16/4. So then we get -4 or 9/2 simplified. Okay, so and that are those are 2 ways to and try to solve this as of now. All right, after we learn completing the square, there can be 3 ways. All right, so now let's look at what we're learning today. So first, we got to review the quadratic formula. All right, so it's going to be -b plus minus the square root of b squared minus 4ac over 2a, right? So if you still have not remembered this yet or written it down anywhere, remember, you can do it right now. Write this formula down, okay? So it's very important, okay? So you can, a big formula, very important formula. So write this down. So one of the tips you can, one of my tips for you is when you're solving with quadratic formula, always write down the a, b, and c, right? The a, b, and c, the coefficients, so you don't get like mixed up. And again, remember to like like move everything to the other side, make it set it equal to 0, or this won't work. And lastly, I want to talk about this discriminant here. All right, this is called the discriminant. All right, so everybody write this down. The discriminant is b squared minus 4ac. Okay, b squared minus 4ac, very important. So you can tell how many solutions you'll have depending on this. How many real solutions you have depending on this discriminant. So if the discriminant b squared minus 4ac is greater than 0, you have 2 real solutions. All right, second case. Let's make it orange now. If b squared minus 4ac is equal to 0, you only have 1 real solution. All right. And lastly, you have, let's make it blue this time. B squared minus 4ac is less than 0. You have no real solutions. You have 2 imaginary solutions. But we don't worry about that yet. We haven't learned about imaginary numbers, and I don't think we will in this class because it's more advanced. We learn about imaginary numbers, so we'll just need to know them. For example, imaginary number is basically I, a square root of -1. Not possible, right? But it is possible, kind of, because this guy decided to invent fake things, so now we have to deal with them. But it's fine because we won't worry about it in this course. All right, so for now, if the discriminant is less than 0, then it's no real solution. So let's see, who wants to volunteer? Okay, so how about Kaylee? All right, so Kaylee, I want you to explain why are these true? All right, are you up for the task?
Can I skip?
All right, so for the first one, right, it's pretty obvious, right? So I'll just do this one for you. So b squared minus 4a, well, ac is for ac is greater than 0. Well, obviously, then the square root is going to be something, right? It's going to be something, and of course, this plus minus makes it 2 solutions, so it's pretty obvious. So could you tell me why b squared minus 4ac is equal to 0 only as one real solution?
Is it because the square root of 0 is 0, and that number plus 0 and minus 0 is still that number?
Exactly. Very good. So if the discriminant here, b squared minus 4ac is equal to 0, then it's just the square root of 0. Whether you add it or you subtract it from any number, it doesn't change, right? So essentially, if b squared minus 4ac is equal to 0, then the solution is just negative b over 2a, right? So there you have it. That's why if it equal to 0, you have one solution. Now, could you tell me why b squared minus 4ac is less than 0? Why do we have no real solutions?
Is that because the square root of any negative number is undefined?
Very good. So if you take the square root of -4, you can't do that, right? It's not -2. If you square -2, it's 4, right? It's not 2 either. So if you square 2, it's 4. So you can't take the square root of -4, right? So it's just not possible. So there are no real solutions. Now let's depict this. Okay, so ever heard of a parabola? This is a parabola. All right, for now we've just been graphing lines, right? We're gonna be graphing these now. Okay. Well, later. This is the graph of a quadratic. All right, it's gonna be like a U shape. It's called a parabola. Now we can see this because if you have x, right? If you have x and y, if you have -2, it's gonna be equal to 4 because y is equal to x squared, right? So basically, and then if you have, for example, let's say -1 is gonna be 1. Of 0, it's 0, 1, 1, and 2, and 4. So if you graph these points, you can kind of see the trend. It's going to be a U, like this. Now that we know what a parabola is, I can kind of depict this with a parabola. So basically, the parabola's x-intercept, you guys know what an x-intercept is, right? When it touches the x-intercept, well, x-axis, then those x points are the solutions, right? That's what x is. Right? If it has 2 real solutions, the parabola is something like this, right? It touches the x-axis 2 times. All right. If it only has 1 real solution, then let's see. How about Ethan? Could you help me on this? All right, Ethan. So, are you up for the task?
Can I skip?
All right. So, Ethan, my question for you is that if there's only one real solution, and what would the parabola for this particular quadratic that only has one real solution, what would it look like? It only touches the x-axis once, right? So
It
what would it look like?
it the tip, I mean the bottom of the parabola only the bottom of the parabola would be touching the x-axis?
Very good. So that's very correct. So by the way, the bottom is called the vertex. All right. So just so you know that when we're talking about parabolas. Okay. So the vertex will be the only thing touching the x-axis. Then therefore there's only one solution, right? Because it's only touching the x-axis once. And if we continue on this, then we know that the third probability, where there are no solutions, then the parabola isn't even touching the x-axis at all. It's just like floating in midair. All right. So this visual depiction for you, it's easier to learn with pictures, and we'll learn how to graph these maybe next class or the class after next class. All right. So today is going to be a lot about square roots, solving with square roots. So let's see here. So example. All right. So this one, well, there are two easy ways to solve this. All right. So let's see who can help us here. All right. Do we have any volunteers? How about Connie? Would you like to help? You can unmute yourself or you can put it in your chat. Okay. So Connie, I have a question for you. So how would you solve this particular quadratic? How would you solve this? All right. So there are a lot of methods to solve this. How would you solve it?
I would probably since there's no x terms with just x in it, I would just say that's 0. And if there's 0 and there's -4, and that means there's two numbers that multiply to -4 and add to 0, and that's 2 and -2. So the solutions for x would be -2 and 2.
All right. So very intuitive answer. Okay. So basically I guess what you did was you moved the 4 to the other side. Well, mentally, right? So then you know that x squared is equal to 4. It has to be equal to 4, so then it has to be equal to 0, right? Because if it equals 4, then x squared equal to 4 minus 4 equals 0, right? So you get your answer that let's say it's -2 and 2, right? And that's very correct. But if you take the square root of 4, it's only 2, right? So how do we get this? Well, you see, a very common misconception is that the square root of x squared is equal to x. That is entirely correct. Incorrect. Entirely incorrect. All right. So don't do that, because if you do that, then you take the square root of both sides, you'll only get it'll only be equal to 2, and that's incorrect because there's also -2. So some people think that it's going to be equal to plus minus x. Not entirely correct. We do come to that later on, but the correct answer for x square root of x squared is going to be absolute value of x. All right, so write this down. Very important. You use this a lot in algebra too, also. So especially the like doing proofs, absolute value equations, that kind of stuff. So you need to know that the square root of x squared is going to be equal to absolute value of x. So the absolute value of x is going to be equal to 4 from this point on. Only in quadratics or only in special types of equations, then this is equal to plus minus well, first the square root of 4 here. So then x is equal to plus minus square root of 4, therefore equal to plus minus well 2, right? So there you have it. The answer is 2. Now let me just quickly show you some other methods. For example, you could factor with difference of squares. So hopefully you guys have not forgotten difference of squares yet. Very important. You can then get -2 and 2 as your roots. You could also use the quadratic formula. A is equal to 1, b equals 0, c equal to -4. Then you're going to get 0 plus minus square root of 0 plus 16 over 2 is just equal to 4 over 2. Well, plus minus 4 over 2. equal to -2 and 2. All right, so the big takeaway from this is how to utilize square roots in your solving. And don't forget that square root of x squared is equal to absolute value of x. Big takeaway. So let's just talk about absolute value for a second. Review, just a little bit of review. So absolute value of x is equal to positive x if x is greater than 0. And negative x um, if x is less than 0. So let's just do this. So how to utilize this actually? So let's say that 3 minus x if x is greater than 3. All right, so then what is this equal? Right? Because x is greater than 3, what would 3 minus x be? All right, so does anybody know what would 3 minus x be if x is greater than 3? All right. So let's see. Hugo, would you like to help us on this?
Okay.
All right, so if x is greater than 3, let's say x is 4, then 3 minus 4 has got to be negative, right? So
Yeah.
then what would this then we write this absolute value without the absolute value. What would this equal without the absolute value? Take a reference to this.
Um. Then the absolute value would equal to whatever the number is without a negative sign. Right? No.
3
No,
minus
wait.
x is going to be negative, all right?
Yeah, it's gonna be negative. So you can't.
It's going to be this one, right?
Yeah. Yeah.
Negative 3 minus x, right? So then it's going to be x minus 3. All right?
Yeah. I get it.
So let's try another one to go. Okay, so with absolute value, let's say we have absolute value of x plus 2 if x is less than -2.
Okay.
What would
So less than -2. So that means negative. So the answer will be positive. So x will be greater than 0. So the answer is x. So the answer is uh x plus 3. No. X is greater than 0. Yeah, x is greater than 0.
Yeah, are you sure about that? Look, if x is less than -2,
Oh no,
right?
wait, no, I thought it was greater. Never mind. No, x is it's negative. So
So then it's negative x plus 2, right?
negative x plus 2, yeah, and so it equals to negative x minus 2.
Very good. So that's how we exploit absolute value to solve these kind of problems. Okay. So I just want to talk about absolute value for a little bit because since we're dealing with that in this situation, so now let's go on to completing the square. So let's use an old example. All right. So let's say x plus x. How to do this? Okay. So all right. So the idea with completing square is that you have. So let's say, do you guys remember this example, right? This example, this particular formula, this is equal to x plus y squared. And we want to exploit this. Okay, so let's say that you have hypothetically x squared plus 2xy here is equal to 0. what can you do to create this, right? You got to add y squared to both sides, right? So x plus 2xy plus y squared to both sides. Then you get that x plus y squared is equal to y squared. Then you can square root that, so absolute value to y. And assuming that y is a real number, then it's just equal to y by principal square root. And then, or plus minus y, okay? Well, not yet, actually. Not yet. We set the absolute value. And then after you reveal the absolute value, it's going to be plus minus y. Okay, so then it's just it's equal to y plus minus y. Okay, something like that. Okay, that's just hypothetical. I just made that up. Okay, so let's try this with a real thing. Okay, so let's try it with this this example. Right, so we want to do something that actually we can't do this. Can't do this because we can already solve this without completing the square. So let's try something else. Let's try x squared plus 4x. Let's go to 0. And because if it doesn't have an x term, then it's so easy to solve. You don't even need to complete the square. But let's do this without factoring. So let's say without factoring, if you do, we already know the answer, right? It's going to be 0 and -4. Those are the answers. Okay. So let's try it with completing the square. So we need to make, ideally, since this is our term here, ideally we want to make this, right, is equal to x plus 2 squared. All right, ideally we want to make x plus 2 squared. So what we need to do is to actually add 4 to both sides. All right, then this is going to be equal to x plus 2 squared, right? It's equal to 4. Then use square root, so x plus 2 is equal to plus minus 2. Then x is equal to -2 plus minus 2 equal to -4 and 0. Okay, so then you compare, it's the same. All right. So does everybody understand how we get this completing the square? Are there any questions, all right, in completing the square? All right. So if there are no questions, I'm just gonna go for a general form for completing the square. All right. So we have ax plus bx plus c. So if you have an a term here that's non-zero and it's not 1, so you have 3x plus 4x. Obviously, you can't have the 3x. Then you can't complete a perfect square. So let's just divide ax everywhere. So x squared plus b over ax plus c over a is equal to 0. X squared plus b over a is equal to negative c over a. To complete the square, we need to, actually, this is because this is plus 2xy, right? It's basically, we need to, it's going to be b over 2a squared is equal to negative c over a plus b over 2a. By the way, it's okay if you don't understand this fully, but you can always try this out later. It's real fun. Okay, then this part is going to be x plus b over 2a squared. Okay, then this part is going to be equal to negative 4, 9. Let me square this out first. Make it clear, 4ac minus a squared c plus ab squared over 4a to the cube. So then you get rid of the a. You don't like that. Plus b squared over 4a. And then you square root x plus b over 2a is equal to the square root plus minus square root of b squared minus 4ac over 2a. Okay? X is equal to negative b over 2a plus minus square root of b squared minus 4ac over 2a. X is equal to negative b plus minus square root of b squared minus 4ac over 2a. What is this? This is the quadratic formula. And that we've proved the quadratic formula. How wonderful. With completing the square. That is how you prove the quadratic formula. All right, so everybody, it's okay if you don't write this down, right? Once you grow older and you actually understand how to use completing the square, then you can probably prove it yourself anyways. All right, so it's pretty simple proof algebraically. All right, it's simple algebraic calculation and just very, you just follow it, just keep simplifying every time. All right, so that is, you just isolate x, right? So that's fine. Okay. And assuming A, B, C are real numbers, of course. All right. So that's it for proving the quadratic formula. So let's actually do some practice problems with completing the square. So I'm going to walk you through this one on the first one. So actually, let's find a volunteer. So who wants to volunteer for this one? Let's see. Eric, you want to help us? All right, let's see who else is here. How about Connie? Would you like to go for this one?
Okay.
Okay, so let's just have you complete the square then. First of all, what square are we trying to complete? This is the key here. It's going to be x squared plus 6x plus something is going to be x plus that something squared. Well, let's test it. X plus 2 is equal to, well, squared is equal to x squared plus 4x plus 4. And x squared, x plus 3 squared is going to x squared plus 6x plus 9. I see it's this part that defines what we need, right?
Yeah.
So basically, we need x plus 3 squared, right? So how are we going to get this 9? We have an 8. Do we need to add 1 to it? Yes, we do. So plus 6x plus 9 is equal to 0. Then we continue on. This is correct. Do you think this is correct?
No.
All right, so what is incorrect about this? It's because we didn't add 1 to the other side. So a lot of people make this mistake. Always remember to add the thing to both sides. All right, so to both sides, come on. The very basic stuff, and you can make a very bad mistake if you don't do it. And so let's make this into x plus 3 squared is equal to 1. X plus 3 is equal to plus minus 1. X is equal to negative 3 plus minus 1 is equal to, let's say negative 2 and negative 4. All right, and that's our answer. Okay, quite simple. Now let's try this next one. All right, the last one is a bit of a challenge, actually. Bit of a stretch there. It's kind of sad. But anyways, let's try the second one. Let's find another example. Volunteers. How about Kaylee?
Okay.
All right, so Kaylee, this defines what we need here. K squared minus 12k. And let me just tell you, look, so x squared plus 2xy plus y squared. You need to find this last number. And this last number is going to be half of this number because it's 2xy. Assuming that y is like 1 or something, right? Okay, and then you can see that we have negative 12, right? So then y must be half of that. It's going to be negative 6. So the perfect square is going to be xk squared minus 12k plus negative 6 squared, which is plus 36. This is going to be x, well, k, going to be k minus 6 squared. And that's our perfect square. So we need to get a 36. All right, so we need to make this 23 into a 36. All right, Kaylee, what do we need to add here to make it a 36? What did you say?
13.
13? All right, so very good. Let's make this into 36 by adding 13 to both sides because we don't want to forget that. Then k minus 6 squared is equal to 13. K minus 6 plus equals plus minus square root of 13. K is equal to 6 plus minus square root of 13. Can't really do anything now because it's a radical and we don't know how to simplify those yet. Well, actually, it is already simplified. So we're done. Okay. If you use the quadratic formula, you get pretty much the same thing. All right. So now let's try this last one. All right. I need one more brave volunteer. Okay. So let's see who wants to do this. Are there any volunteers? Any volunteers? You can raise your hand if you want to. All right. How about Jenny? Jenny, do you want to go?
Okay.
All right. So let's just move. I'm just going to move everything to one side for you first. All right.
Okay.
Well, kind of need to leave the negative 4 over here because I guess because yeah, let's just leave the negative 4 over there for now. Okay, so what we need to do is divide by 3, right? So Jenny, what are the terms now if we divide everything by 3?
Divide
X
everything by
squared, right? And then
a over 3x negative 4 over 3.
all right, very good. So now that we've seen the defining factor, basically the first x squared minus 2xy, all right, what is half of 8 over x? 8 over 3x. Well, half of 8 over 3. What is half of 8 over 3? It's just negative 4 over 3, right?
Yeah.
So half of 8 over 3 is just 4 over 3. So you see our perfect square here is going to be equal to 4 over 3 squared. So it's going to be x minus 4 over 3 squared. All right. So let's just make it x minus 4 over 3 squared. Don't forget to add this to the other side. All right, that's just equal to negative 12 over 9 plus 16 over 9 is equal to 4 over 9. Okay, next. All right, so let's just go on to our next step, right? Let's just square root this is equal to what? Plus minus 4 over 9, right? Then our next step is we need to move it to the other side. If we move it to the other side, it's going to be plus minus 4 over 9. You can see that it's basically, again, x is equal to 12 over 9 plus minus 4 over 9, which is, hold up a second. Is this correct? So then we get 16 over 9 and then 8 over 9. I don't trust this answer. No, this is not correct. All right, so let's see where we went wrong here. So it's 4 over 3 squared. Should be. All right, and then, oh, we forgot to do the square root. Okay, I see where the problem is. All right, so you forgot to do the square, so don't do that. All right, so it's going to be plus minus 2/3. All right, there we go. And it's just going to be equal to 4 over 3 plus minus 2/3. That's going to be equal to 2/3 or 2. All right, so those are our two answers. This is one of the very bad situations that I would recommend not using completing the square, because of course there can be a lot of problems and fractions we just don't like in general. I don't think you can factor this. You could try. First, of course, always try factoring. Best method. Maybe use quadratic formula on this one. I would use quadratic formula on this one. All right, so completing the square, very useful, not always the best thing. All right, so you need to decide when you need to use these. All right, so not always the best thing to do for one method. So it's good that you get taught all of these methods. All right, so you just don't use the same method over and over again. It can get very tedious, and fractions when fractions decimals are involved, right? So that's it for today. All right, that was just completing the square, which is all we have for today. Okay, so I'll see you guys next week.